Well, good evening, everyone. I'm Matthew here in the observatory at the South Carolina State Museum. It's great to see everyone here. Sorry for the late start. We had a few little technical glitches that decided to all happen at once, which are now fortunately resolved. So hopefully things will go more smoothly for the rest of the evening. We're looking tonight at the Andromeda Galaxy. We'll be looking at the Andromeda Galaxy view until about 8 o'clock or a few minutes after. And then as we get to the top of the hour, we'll switch over to a view of the Blue Snowball Nebula. Very appropriate name for an object, given that we're going into the winter and the holiday season now, I think. Now, if you have any questions, feel free to pop those questions in the Facebook or YouTube chats. I will see those questions right here, and we'll be happy to answer them. I should tell you that we're actually not seeing images from the telescope right now. Tonight, it's kind of cloudy. It's not really completely cloudy, but we've got a lot of these high clouds and kind of icky stuff, which is hard when it comes to looking at these fainter objects that are really far away, like the Andromeda Galaxy. So actually on Thursday, after we had our planetarium holiday lighting event, I did some imaging. I actually got some images of the Andromeda Galaxy and Blue Snowball Nebula uh, to uh, to share tonight, just in case we had cloudy weather. And sure enough, it looks like my imaging paid off. So this is this past Thursday's view of the Andromeda Galaxy right here. It's that sort of fuzzy thing you see in the middle. It has a kind of pointy center that's called the nucleus of the galaxy, and then you can see all of that fuzzy haze around it. So this galaxy is about the same as the Milky Way galaxy. It's also a spiral galaxy. It's maybe a little bit bigger than the Milky Way, but very similar in structure. Um, this galaxy is about 2.5 million light years away. So 2.5 million light years away. A light year is the distance that light travels in 1 year. So who wants to try putting in the comments how far back in time we're looking when we look at this galaxy? How long did it take the light to reach this, get to us from this galaxy? If the galaxy is 2.5 million light years away, and a light year is the distance light travels in 1 year, how long did it take the light to get from this galaxy to our telescope this past Thursday evening? So pop that in the comments if you want to take a stab at it. And I'll just hang out and see if we get some responses. And once again, as a reminder, please feel free to ask any questions you might have in those comments as well. So once again, how long do you think it took the light to get from this galaxy to us here on the Earth if it's 2.5 million light years away? I'll give you a hint. When we look at distant objects like faraway galaxies, we're actually looking back in time. So how far back in time were we looking? Oh, Vicky says 2.5 million. Very cool. Yeah, so we're actually looking about 2.5 million years into the past when we look at this galaxy. Now, this is a pretty nearby galaxy. It's actually the nearest big galaxy to our own. But this means that if you're looking at something really far away, like a galaxy that's maybe not just 2.5 million light years away, but say a billion light years away. If you're looking at a galaxy that's a billion light years away, you're actually looking a billion years back in time. So basically, as you look further out into space, you're looking further back in time. So you can think of a telescope as kind of a cross between a spaceship and a time machine. So, just once again, if you're trying to figure out which of what you're looking at is the galaxy, it's that kind of fuzzy thing pretty much in the center. It's a little bit above center, but it's that fuzzy, hazy thing. It kind of has a point like center. That's called the nucleus of the galaxy. And then you can see all that haze around it. That haze is actually just a whole lot of billions of stars. That's actually where the spiral arms of the galaxy are. Um, well, actually, the spiral arms of the galaxy are a little further out from that haze you're seeing. We're actually really only seeing the center part of the galaxy. And that's because when we're looking at this galaxy under skies with a lot of light, like we have here in downtown Columbia, then we don't see the whole galaxy. We have to get under a dark sky to see the whole galaxy. Now, all those little pinpoint things around the galaxy, those little white spots, those are actually all stars. Those are actually stars in our own galaxy that happen to be in this same area of the sky. So those aren't stars that are part of the Andromeda Galaxy. Those are stars that are in our own galaxy. Once again, any questions? Feel free to pop those in the chat. Tonight's kind of different from our previous live streams because we're showing these what we call deep sky objects. These are objects that are far out beyond the solar system. So things like nebulae, star clusters, galaxies. These are the far away things. And of course, this is another galaxy. When we switch over to the blue Snowball Nebula in a little while, that'll actually be something that's within our own galaxy. So, how many stars do you think this galaxy has? Just take a wild guess and put that in the chat. How many stars do you think are in this galaxy? So do you think this galaxy has like several million stars or several billion stars? Is it maybe more like 100 billion stars? A trillion stars? What do you think? How many stars do you think are in the Andromeda Galaxy? I'll give you a hint. The Milky Way galaxy, our own galaxy, has about 100 billion stars in it. All right, I have a vote for 6 trillion stars, over 100,000 million. Any other ideas? How many stars are in the Andromeda Galaxy? I'm going to see if we have any other guesses before I do the grand reveal and tell you how many stars are in this galaxy. Any Their guesses for the number of stars in the Andromeda Galaxy. Going once. Going twice. Well, so when I looked it up, see if a vote there for 200 billion. When I looked it up, I saw the Google showing. So Google says that this galaxy has 1 trillion stars in it. So 100 billion stars in the Milky Way, 1 trillion stars in Andromeda. What you'll find is that these estimates vary. Some astronomers estimate that the Milky Way galaxy could have as many as 400 billion stars. So the Andromeda Galaxy is a little bigger than the Milky Way. So it probably has, if it doesn't have quite at 1 trillion stars or so, it's probably approaching that. So several hundred billion stars. So just think about that. This little hazy spot that you're seeing in this picture is actually several hundred billion stars. Doesn't look like that, but that's actually what you're looking at. Several hundred billion stars really far away. And again, the Andromeda Galaxy is about 2.5 million light years away. And a light year is the distance that light travels in 1 year. That's about 6 trillion miles. So if you want to figure out how far it is to this galaxy in miles, multiply 2.5 million times 6 trillion, and I dare you to do that math. That's why astronomers use light years, because the distances are so huge. Another way to think of it is that if we could somehow travel at the speed of light, it would take us 2.5 million years to get to this galaxy. And that's at the speed of light. And this is a nearby galaxy. This galaxy is a next door neighbor. This is kind of like you going from maybe your house, if you live in a house, to the house next door, or maybe to the apartment down the hall if you live in an apartment complex. Basically, this is a next door neighbor galaxy to us, and it's already that far away. So if you've just joined us, we're looking at a view from our telescope here at the museum's observatory of the Andromeda Galaxy. This is actually an image that I took back on Thursday night when the sky was a lot clearer than it is tonight. Tonight, the sky isn't completely socked in. If you go out, you'll probably still see some of the brighter things like Jupiter and Venus. But the high clouds that we have tonight are actually not really good to be looking at these far away faint objects. So I looked at the weather forecast a couple of days ago and I saw the partly cloudy forecast. And I thought, yeah, this could be interesting. So on Thursday, when we had a much more clear sky, I actually stayed around and did some imaging. So we'd actually have these pictures for tonight. So you're looking at Thursday night's picture. That's why if you look behind me, you can see the telescope and we have the lights on in the observatory. The dome right now is actually closed. So I've got another one of my crazy questions for you. Take a wild guess. How many galaxies do you think there are in the universe? So how many galaxies do you think there are in the universe? Catherine says, we don't know for sure. That's a good way to put it. We don't know for sure, but astronomers do have some kind of estimate. Vicky says 200 billion. Okay. Any other ideas? The number of galaxies in the universe. Tonight's like really far away, big universe galaxy night. Any other guesses for the number of galaxies in the universe? Amy says 125 billion. So, Catherine, you're absolutely right. We do not know for sure. So, with Vicky and Amy, Catherine comes back and says 3 trillion. So, with Vicky and Amy, 200 billion, 125 billion. Basically, astronomers estimate that there are probably somewhere around 100 billion galaxies in the universe. We don't know for sure, but that's kind of our current best estimate. So, 100 billion galaxies in the universe, each of which can contain as many as 100 billion or even upwards of a trillion or more stars. So it's really hard to wrap your mind, in fact, pretty much impossible to wrap your mind around how big the universe is. Our own galaxy is about 100,000 light years across, and the Andromeda Galaxy is going to be similar to that, actually a little larger. So something interesting is going to happen with the Andromeda Galaxy and the Milky Way in several billion years. Does anyone know what that might be? If you have a guess, put it in the chat. What do you think is going to happen between the Milky Way and Andromeda Galaxy in several billion years? Catherine says merge together. Amy says merge. Implode. So basically, what's going to happen is the Milky Way and Andromeda Galaxy are actually moving closer to each other. Most galaxies are actually moving away from us, so that's kind of different. The Andromeda Galaxy, though, is moving towards the Milky Way, and it's on a collision course. So in several billion years, the Milky Way and Andromeda are going to run into each other and basically merge and form one really big galaxy, which I've sometimes heard called Milkomeda. Now, what a name for a galaxy, Milkomeda. That's what happens when you combine a Milky Way and an Andromeda, I guess. Yeah, collide and have lots of star babies. Yeah, often when you have galaxies colliding, that really stirs up the gas in the galaxies, and you can get new stars forming when that happens. But when galaxies collide, do you think the stars themselves run into each other? So when galaxies collide, do the stars in the galaxies themselves actually smack into each other? Is a galaxy collision more of a large scale type of interaction, or is it like having a train wreck in space with things hitting each other? Danny says maybe. Okay, Danny says it's more of a large scale thing. Yep. Any other thoughts? When galaxies collide, yeah, right. Catherine says lots of gaseous interactions. So basically, when galaxies collide with each other, the stars don't run into each other. Stars inside a galaxy are so far apart that even if you have galaxies smacking into each other, the stars actually don't run into each other. What happens is the stars will interact with each other, and the gravity from the stars in each of the two galaxies can interact, and it can pull the galaxies into some pretty strange shapes. So interacting galaxies can look pretty weird, actually. So Danny's doing some thinking here about how galaxies collide. Yeah, so the galaxies will actually join, but even when galaxies join, the stars don't really hit each other. But what can happen is, again, the gravity can pull the galaxies into these weird structures where you can have some funny tails. I'm going to give you some names in the comments of some galaxies to look up. There is an interacting galaxy pair called the antennae. I mean, if you do a Google image search for these, and then there's another one that says, you'll love this. There's another interacting galaxy pair called the mice galaxies. Again, do Google image searches for these antennae galaxies and mice galaxies, and you will find some pretty cool pictures. Danny asks, does the galaxy with the biggest star usually win and make a super galaxy? So yeah, in generally, the galaxy that is larger is the one that is going to kind of win the interaction typically. Um, but what's kind of interesting is that may be the case, but even a smaller galaxy brushing by a larger galaxy, that smaller galaxy can kind of mess the larger galaxy up. So there's another example of that to look up called the Whirlpool Galaxy. I want to put that in the comments for you so you can look that up. The Whirlpool Galaxy is an example of a smaller galaxy interacting with a bigger galaxy, and the smaller galaxy is kind of really super messed up, but it's also kind of messed up the big galaxy too. So one fun little question for you. I said something about this earlier, but this is just kind of for fun here. Are those dots that you see, those white dots that you see around the Andromeda Galaxy, are those in the Andromeda Galaxy, or are those stars in our own galaxy? Are those in the Andromeda Galaxy, or are those foreground stars in our own galaxy that just happen to be in the same part of the sky? Danny asked, do the colliding galaxies ever form a black hole? So it's actually really common for galaxies to have black holes in their centers. We have a black hole in the center of our galaxy, and the Andromeda Galaxy has a black hole in its center. And yes, in theory, those black holes could collide and form a bigger one when you have galaxies interacting. Typically, though, what's more common when galaxies interact is that they kind of brush by each other. So it's not that center part of the galaxy where you'd have the black holes that are involved as much as it is the edges. And in just a minute, we're going to switch over and have a look at the blue Snowball Nebula. But before we leave the Andromeda Galaxy, I'll tell you that the Andromeda Galaxy is actually visible um, from a dark site, so you need to be under a very dark sky. The Andromeda Galaxy is actually visible without a telescope. So it's the most distant thing that we can see without a telescope. But again, you need to be under a really dark sky and know exactly where to look to see it. It's not something that we could see without a telescope from here in Columbia. Yep, Michael, that's very true. Black holes do collide and form gravitational waves. Yes. All right, are we ready to have a look at the blue snowball? You're ready to look up at the blue snowball? Put a big yeah in the comments. I see a thumbs up. All right, well, it'll take me just a sec to switch our pictures out. So, oh, yeah, all right, awesome, awesome. Let me switch our pictures out here. You're going to see me close this out. Did I just completely terminate our remote desktop link? I think I did. Oh, well, we'll reconnect and I will go get that set up. Here we go. Give me just a sec. We're going to switch images. All right, here comes the blue snowball, everyone. Just let me get this set up here, get screen share going. There we go. All right. So now we're looking at the blue Snowball Nebula. And the blue Snowball Nebula is that little sort of circular blue thing just a little bit to the left of the center. Now, this is actually inside our galaxy. This is much, much closer to home than the Andromeda Galaxy. The Andromeda Galaxy is about 2.5 million light years away. This nebula is only about 2,000 light years away. So it's still pretty far away, but it's a heck of a lot closer than the Andromeda Galaxy. And it does look blue. In fact, I think the name blue snowball is perfect for an object to look at in a telescope right around now as we're going into the holidays and we're thinking about winter, and maybe if you live up north, snow. Um, some of you might have seen on Facebook, on the museum's Facebook page, or maybe you're actually here on Thursday night. We had our planetarium lighting. So now our planetarium dome here at the museum is all lit up like a snow globe. So if you haven't seen that, come by the museum at night, drive by the museum at night and look at that planetarium with its snow globe illumination. It's really, really beautiful. But here we are in our telescope with a nice holiday object, the blue Snowball Nebula. So this nebula is what's called a planetary nebula. Planetary nebulae have nothing to do with planets, but what they are areas where stars like our sun died and they poofed their outer atmosphere off into space. So that's what you're seeing here. This is actually the leftovers of a star like our sun that came to the end of its life. So, do gravity waves have any impact on space and time? And why is this nebula blue? Okay, so do gravity waves have an impact on space and time? Yes. So when gravity waves happen, they actually can distort, or they do distort, the space-time continuum. So, yep, that's a big general relativity thing, is those gravity waves are actually ripples in space-time. And then why is the nebula blue? What makes it appear this way? So planetary nebulae tend to have a lot of things like Catherine mentions nitrogen. So they have to actually have some interesting gases in them, especially oxygen. It turns out it's actually oxygen that gives a planetary nebula its kind of bluish green color. So it's very common for these nebulae to look kind of blue, look kind of green. Is the blue the only light escaping? So yeah, this nebula is giving off light kind of focused there in that blue wavelength. So one thing I encourage you to do with these planetary nebulae is to look up Hubble Space Telescope images of them. So this is the view of the blue snowball in our small telescope. This was taken through our 12-inch Clark telescope, which is big and spectacular as it looks here in the museum. It's actually a fairly small telescope. So if you point Hubble Space Telescope at something like the or something like rather the blue snowball, it looks really, really amazing. These nebulae look super, super amazing with Hubble Space Telescope images. They have all kinds of interesting patterns in them. Some of them look like maybe a spirograph drew them. You can see all the patterns in the gas. They're just really, really fascinating objects, especially when seen with a very powerful telescope. And there's some other nebulae like this in the sky that have some pretty interesting names. There's the Saturn Nebula, which has a pattern that kind of makes it look like the rings of Saturn a little bit. Again, it has nothing to do with planets, but it's just how that nebula looks. There's another one called the Ghost of Jupiter Nebula. There's the Cat's Eye Nebula. There's a planetary nebula that we often look at in the summertime sky called the Ring Nebula. And then there's the Helix Nebula, the Dumbbell Nebula. These nebulae have interesting names to them. So are there any planets or whole stars in this nebula? So there are very likely no planets in a planetary nebula. So the name is a total misnomer. But inside the nebula, there's what's called a white dwarf. A white dwarf is the leftover core of the star that ended its life right here in this spot. So it's actually the white dwarf actually is quite hot, and energy from the white dwarf is part of what makes the gases in the nebula glow. So yep, there's a bit of a star in there. It's actually the leftover core of the star that was here. And not to put a damper on your evening, I wouldn't worry about this because this is a long way in the future. In 5 billion years, this is what our sun is going to do. It's going to become a planetary nebula. So long, long time. It's going to poof its outer atmosphere off and then turn into a planetary nebula. So when you see planetary nebulae, one of the things that hasn't happened here is this does not represent where a supernova happened. Supernovae happen with much larger stars than the stars that form planetary nebulae. And Michael brings up the Horsehead Nebula. The Horsehead Nebula is actually a different type of nebula from this one that we're seeing tonight. The Horsehead Nebula is actually basically a dark cloud of dust with some gas thrown in it. It's called a dark nebula. But that whole part of the sky, the Horsehead Nebula, there's the Orion Nebula, there actually are different types of nebulas. Again, with the blue snowball, we're looking at a nebula where a star died, but with objects like the Orion Nebula and the Horsehead Nebula and that whole part of the sky, we're actually seeing places where stars are being born. And one of the things that we're going to look at on this live stream as we get into the winter, so as we get a little bit into January and February, is the Orion Nebula. Right now, the constellation Orion is rising in the east just as it's getting dark, so in the early evening. And then as we get into the winter, the Orion Nebula will be beautifully high up in the sky in late January and February in the early evening, and well placed for us to get a look at that beautiful nebula from our telescope. So that's something to watch out for as we get into the new year, is the Orion Nebula. How long ago is it estimated that this star died? I am not sure. Let me see if I can find out for you. Typically, with these planetary nebulae, it's been fairly recently, like within, and you'll laugh when I say recently, within the past like few 100,000 years, which less than 1 million years. That's not very long in terms of space. So I'm just curious if we can get kind of an estimate of when this nebula formed and how old it is. Yeah, they're actually relatively recent. Let's see here. Does this tell us? No, it doesn't. But yeah, typically with planetary nebulae, they're actually usually less than 1 million years old. And part of that is what's happening is that gas you're seeing is actually expanding off into space. So as planetary nebulae get older, they get more and more diffuse. That gas gets further out into space and they kind of fade out over time. So we don't see them when they're really, really old. Because basically that gas just disperses back out into space. And then that gas from a star that died can actually get incorporated into new stars. So Vicky says, there's been a pretty bright object in the northwest sky. It looks like it is two objects with one in front of the other. The one in the foreground is white and the one in the background is red. What two objects are they? I thought one was Venus, but I'm probably wrong. And there's Anita. Hi there, Anita. This is the blue Snowball Nebula right here. So if you're looking off in the northwestern sky, or generally the western sky, you're going to see Venus. Venus is actually going to be more in the southwest, and it's very, very bright. Super, super bright. It'll really catch your eye when you look at it. Jupiter's also kind of in that part of the sky. It's a little higher up and further up in the sky. And then Saturn is between the two and quite a bit dimmer. So I'm not sure what that would have been in the northwest sky, because all those really bright objects like Venus are in the southwest sky right now. And Danny says, yeah, doesn't it take a while for the light to register to us? Yes, that's absolutely true. So with the Andromeda Galaxy, remember, we were looking at an object that was 2.5 million light years away. So we were actually looking 2.5 million years back in time. When we're looking at closer objects, at objects that are still pretty distant, this is also true. So if this nebula is about 2,000 light years away, we're actually seeing it as it was 2,000 years ago. So we're again looking back into time. Yep, so it takes a while for the light to reach us. I think this nebula is kind of fun because it really does look like a snowball. So it looks like we just had a bunch of people join us. So if you just jumped on, we're looking at the Blue Snowball Nebula. This is an area where a star like our sun died several 100,000 years ago, probably. And it really does look like a blue snowball. So I thought it'd be a great thing to look at right now as we're going into the holidays and thinking about winter and snow and Christmas and all of that. Now, unfortunately, this isn't an image that we're seeing right now. Tonight, it's kind of cloudy. It's not completely cloudy, but it's cloudy enough where we would have a hard time seeing these fainter, farther away objects. So on Thursday, after the planetarium lighting, I actually hung out in the observatory and took some pictures for tonight. It was actually a much clearer night on Thursday, so I was able to get some pictures to use tonight because I looked at the forecast a few days out and I thought, yeah, I'll bet Saturday is going to be kind of cloudy, especially if we're trying to look at these faint things. And sure enough, it was. So, not to fear, we got some great images from just a few days ago here. And if you've just recently joined us, if you have any questions, feel free to pop those in the chat, either the Facebook chat or the YouTube chat, depending on where you're watching. And we will um, answer them. Oh, Vicky follows back up. Okay, so yeah, it's the same area as Jupiter and Saturn, but more to the right. Yep. If you're looking off to the southwest, Venus will be the furthest over to the right and the lowest in the sky. That's Venus there. And then Jupiter is not quite as bright as Venus, but still pretty darn bright, and it's up higher. And then Saturn is the dimmest one, and it's in between the two. So Vicky's asking about Venus in the front, and then there's M8, the Lagoon Nebula. So the Lagoon Nebula is a nebula in the constellation Sagittarius. Um, that nebula is actually more something that we would see in the summertime sky. So it's not in the sky right now. Sagittarius really is pretty much sets with the sun right now. And it's, again, the Lagoon Nebula is actually more like the Orion Nebula. The Lagoon Nebula is an area where stars are forming. Then we have a question about the Christmas star. So you might be thinking of Venus. You might also be thinking of Jupiter and Saturn, which had that super close conjunction last year, right before Christmas. So this year we don't really have like a Christmas star event. That Jupiter and Saturn conjunction was referred to often as the Christmas star because of how close they're going to be and the timing of it. So yeah, Christmas star viewing, not so much. Although Venus is kind of being a nice Christmas-like star right now, being so bright in the early evening. Yeah, there isn't actually like a Christmas star. Um, so last year we had that event with Jupiter and Saturn really close together. But yeah, there's not like a Christmas star. And there actually, of course, there's in the story of the birth of Jesus and the Bible, there actually is, of course, the Christmas star. And there are several possible explanations for what it could have been. We're not really sure, but it could have potentially been a comet. It could have been a planetary conjunction like Jupiter and Saturn that we had last year right before Christmas. It also could have been a supernova, so a star exploding and being really, really bright in the sky. When stars, really massive stars, blow up at the end of their lives, they actually can become very bright in our night sky if they're close enough. So there are a lot of possible explanations for what the Christmas star in the Nativity story was. Um, it's really hard to kind of pin it down to one. Um, but yeah, that's actually kind of the Christmas star is kind of something that's in our storytelling and our mythology, and especially this time of year. Did any of you see Jupiter and Saturn last year really close together? It was like either December 20th or December 21st or something like that. Um, it was they were right close together, but you could still see there were two objects, and it was really clear weather. So did any of you actually see Jupiter and Saturn right next to each other? Amy says yes. Fantastic. So this is actually, as we get a little bit towards the end of our time, I'm going to tell you something that's really kind of a different subject, but really cool. It's something I like to talk about at this time of year every year. Today, December 4th, is actually the day of our earliest sunset here in Columbia. It's not our longest night. Our longest night is the winter solstice, so December 21st, 22nd. It sort of shifts around a little bit every year. But tonight, the sun set as early as it's going to all year. Our sunset time tonight was 5:14 p.m. So as we go into the next few days and weeks, the sun is actually going to start setting a little bit later. And by month's end, you might be starting to notice that a little more, that it's brighter for just a few more minutes in the evening. What happens though is that sunrise also gets later, and that's why when we get to the solstice, that's still our longest night. And then sunrise actually doesn't start to get earlier until about 2 weeks or so, maybe more like 10 days or so into January. And Anita asked about meteor showers. Yeah, so I think it's the Geminid meteors. They're like December 13th and 14th, so they're coming up pretty soon. But yeah. Yeah, and Michael's mentioning the Jupiter and Saturn conjunction. Right, it was actually not nearly as dramatic as an event as a total solar eclipse was. It was kind of played up in the news a lot, and then I think a lot of people were expecting to see more than actually what happened. Never happens, does it? Thank you for joining us, Anita. It's always great to see you on these programs. So yeah, that's something to watch for. I was mentioning earliest sunset today. Its sunset's still going to hang out around 5:14 for the next few days, but as we start getting closer to Christmas, start seeing if you can notice that the sun is actually setting just a little bit later each night. So let me see if I can find my info here on sunset times. I actually looked those up for Columbia. So on Christmas Day, our sunset will have actually moved to 5:21 p.m. So it will be like a good 6, 7 minutes later than it is tonight. And then by the 31st, so at the end of the month, our sunset will be 5:25 p.m. Um, so we'll start to notice that the sun starts to set later, even as we get towards the solstice. But remember, sunrise is also getting later too. And Michael's like, I want Betelgeuse to blow up as a supernova. Yeah, that would be kind of cool, wouldn't it? That'd be quite an event if it happened in our lifetimes. So we got started just a little bit late, so I'm going to keep it up for about another 2 minutes or so. Are there any last minute questions before we call it a night? Feel free to pop any of those in the chat. Thank you, Anita. Good night. We'll see you next time. So I should just mention our next live stream is going to be, let me remind myself of the date so I don't tell you something goofy. It's going to be on December 18th, same time, 7:30. Um, so that will be just a few weeks from now. So Saturday, December 18th at 7:30 again. Pulsars and quasars. Yeah, that's actually something we can talk about. Really, really cool stuff there. All right. Well, we're going to go ahead and call it a night. Thank you all so much for joining us, and we'll see you hopefully on December 18th for our next telescope live stream. You'll have a wonderful evening, all the best, and have lots of fun as we celebrate the holiday season, whichever holiday you happen to be celebrating. And then we will see you later. Bye, everyone.